Let's look at composite functions. We have two functions, the function f, which is a straight line, 2x plus 1, and it has a restricted domain. And we have a second function g, which is a quadratic, x squared plus 2, with no restrictions. Now we're going to be asked to find the composite function of these. In particular, the composite function g of f. So what that means is we're substituting f everywhere we see an x for g. And we'll do some examples of that. Now, some other notation you might see for a composite function, instead of writing g of f of x, sometimes you'll see it like this with a little circle. So these mean the same thing. G with brackets of f of x, or g little circle f of x. Okay, let's work out what these composite functions mean. Let's look at f. This part here means we just need to substitute 1 in for x into our function f. So let's work that out. F of 1 is 2 lots of 1 plus 1, which is equal to 3. So we've done this bit now. That bit there equals 3. So to now evaluate the rest of it, to now do this part, we just do g of 3. So everywhere we see x in g, we substitute 3. So 3 squared plus 3, 9 plus 3, 12. So to answer the whole question for part A, g of f of 1 was equal to 12. This part here was equal to 3, and then g of 3 was equal to 12. So that is part A done. So part B gets us to do the same thing, but instead of substituting a number, we're going to just leave x as it is. So I'll start by writing out g here. And instead of writing f of x, I'm going to substitute what f of x is for in here. So I'll write g of 2x plus 1. Now what we need to do is substitute this in for g. Just like we did here, we substituted in 3 in, and we did 3 squared plus 3. Instead of substituting in 3, we'll substitute in 2x plus 1. So instead of x squared, we'll substitute in 2x plus 1 squared. And we can expand that if we like, or we can just leave it in that form, that's fine. Okay, now for where it gets a little bit tricky. Finding the equations isn't too bad. Now we need to find the domain and range. Now, looking at this is a quadratic, and it's in turning point form, and you can think of it as a quadratic that has been moved left a half and up 3. So if we look at a graph of that, quadratic's a positive quadratic, left a half, up 3, there's its turning point, looks something like that. So the domain of this quadratic would be all real numbers, and the range would be 3 up to infinity. So square bracket including 3 up to infinity. Now, unfortunately, that's not always the case for the answers for part C and D. This happens to be the range and domain for the equation 2x plus 1 squared plus 3, but it's not necessarily the domain and range for the composite function g of f of x. And we're going to look at why by drawing some function machines. So to draw some function machines, you need to think about a conveyor belt and what's going in first and what's going into what and out of what and in what order. So let's think back to the start here. when we substituted in the number 1. 1 went into F first, then we got that answer, and then we put it into G. We substituted in 1, we got an answer of 3. We substituted in 3 into G, and we got an output of 12. So if we think of this as a conveyor belt, we substituted in 1 into F, got an answer of 3, which we subbed into G and got an answer of 12. So we're going to draw a function machine that does this. We're going to have stuff going into F, and then that goes into G and comes out the other end. So I'll have a function machine over here, 2x plus 1. So this is F. Stuff will go into F and it will come out, which continues on into G. So this is G, and then stuff eventually comes in, out the other end. So from our previous example, 1 came in, 3 came out, 3 went into G, and 12 came out the other end. Okay, so let's try and work that out in general for any x value or the domain. So it's really helpful if you draw yourself some graphs of these functions underneath so you can really quickly read domain and ranges of your graphs. So this is a straight line. It's been moved up 1 and has a gradient of 2. So we'll have a y-intercept at 1 and it will have a positive gradient. But, and here's the key thing, there is a restricted domain over here between -1 and 3. So I do not want the whole line. I only want a section of the line between -1 and 3. So we'll go to -1 and we want to take that portion. I'm going to have a colored in circle because it's a square bracket, so we're including that point. So at x equals -1, let's work out the y value. 2 times -1 is -2 plus 1, -1. So this coordinate is -1, -1. And we stop at x equals 3. So let's work out the y coordinate of this point. Oops, that should be an open circle because it's a round bracket, so we're not including it. So at x equals 3, we have 2 times 3 is 6, plus 1 is 7. So that coordinate is 3, 7. And we only want this portion of the line. Okay, so that's the restricted line segment between -1 and 3. So our domain is -1 to 3, and our range just for the f function was -1 up to 7. So it's including -1, not including 7. Okay, x squared plus 3. This is easy, no restrictions, so it's a parabola that's been moved up 3. It's a positive parabola, so it's a happy smiley face. Our domain for our parabola is all real numbers. And our range is 3 up to infinity. We can include 3, so square brackets. Okay. If you set yourselves up with these graphs at the start, it's going to make reading the conveyor belt along here much easier. So I really recommend doing that. So here we go. Instead of just sending in a single number like we did before with number 1, we're going to send in all possible x values that we can. So all possible x values, or another word for that is the domain, is between -1 and 3. So anything that can go in, oops, -1 and 3. They are all possible x values that can go in. And what comes out the other end are all the possible answers we could get, or y values, or range. So the stuff coming out is between -1 and 7. Okay, so this now gets fed into G. So we're going to pass -1 to 7 into G. And here's where the issue is. Our original G function had a domain of all real numbers. But we can't have all numbers coming in because now we're restricted between numbers between -1 and 7. So where originally G could have had, say, x equals 10 come in, which would have been an allowable number, we can't get 10 coming out of the function f. So we've got a restriction. So now what we need to do is work out, with this restricted domain, what will be the resulting range coming out the other end. So in fact, this is no longer useful for us. So we're going to draw a new graph and work out our new implied domain. So between -1 and 7, we'll start here at -1 up to 7, turning point at 3. Square bracket at -1, so we'll have a closed circle, and then we'll come down to 3 and up to 7, open bracket, so open circle. Let's work out these y values. So at x equals -1, we have -1 squared is +1 plus 3 is 4. So the coordinate -1, 4. At 7, 7 squared is 49 plus 3 is 52. So 7, 52. So the range with our restricted domain, now be careful here, a lot of people will say the range is 4 to 52, but it's not. We have a turning point that goes all the way down to 3. We include 3, so we need a square bracket, and all the way up to 52. But we have an open circle, so we'll have a round bracket there. So the stuff that comes out here is 3 to 52. Okay, so we've done all that hard work. We can now answer the question. Our domain of g of f of x is what we sent in at the start. So that is our domain, -1 to 3. Our range is what comes out at the very end, 3 to 52. Now let's just test that. Let's see if we send in some numbers to see what happens. Let's send in -1, which is one of our endpoints here, and see what comes in at the end.